In this video, we will learn more about energy, its units, and some laws, and how it works with how it is related to chemical reactions. We'll introduce that as well. So, first, law of conservation of energy. What does this state? This states that energy can neither be created nor destroyed. This is law of conservation of energy. Law of conservation of energy. You cannot create or destroy energy, but energy can transfer from one object to another object. It can assume different forms. So, a certain object might have kinetic energy first. Then you perform a reaction on it, it turns to maybe potential energy. So it can transfer from one object to another, or it can change forms. Now, how do you track these energy changes? How do you track energy changes? To track these energy changes, we first define system and surrounding. System is something that is under investigation. This is under study. You're studying something. It could be under study, This is under study, under investigation. You are studying something. It could be all chemicals in a beaker. All chemicals that are going through the reaction. All chemicals in a beaker. Or it could be one particular chemical that you are interested in, right? If you are looking at a reaction where iron is reacting with something to undergo a transformation, and you want to see what is happening to iron, how much of iron is reacting, for example. So iron becomes your system. So then if you define a system, then you can actually track this energy changes. Now how many types of systems are there? There are 3 types of systems. Open systems. These exchange mass and energy. And then there is closed system, and they exchange energy. And then there is isolated systems that do not exchange mass. So no mass exchange and no energy exchange. No mass exchange or no energy exchange. What does this mean? So consider a beaker of water consider a beaker of water. Consider a beaker of water with lid on top, and consider a thermos flask with water, with hot water. Now let's say this has, all three of them have hot water. All three of them have hot water. But they are placed in different types of containers. The first one no lid, the second one has a lid, and the third one is a thermos container. In this case, some water will evaporate, and when you touch it, you will feel that it is hot, right? So after some time, amount of water will decrease. So that means this system gave away some mass of water. Depending on what temperature and other condition, the mass can be less or more. So there was exchange of mass, and when you touch it, this was hot. The first one was hot. So some energy transferred to your hands. Now let's talk about the second container. All the water, there might be movement of water vapor, but the water will stay here because there is a lid. So what will happen after some time? This water will come back into the bulk of water. The water can be seen as falling back into the bulk water. So there was no mass exchange. None of the water that was present in the second container could get out. That didn't happen. Although when you touched the second container, it was hard to touch. So some energy got transferred into your hands. Okay, the person who was touching the beaker, the energy got into the hands. What about a thermos flask? That didn't happen in thermos flask. Thermos flask, the hot water, you couldn't feel that the water was hot. Okay, when you hold the thermos, you don't feel that the water is hot, right? For some time, that water will hold that temperature depending on the type of flask. So for that time, depending on the type of thermos flask you're using, for that few hours, no mass exchange, no energy exchange. No mass or no energy exchange. So what is surrounding? Surrounding is the environment that is in contact. It is in contact with the system. The environment in contact with the system with which system can exchange energy. System can exchange energy. So in this example right here, this is an example of open system. This is an example of a closed system, and this is an example for isolated system. Although this is not going to be isolated for a long time. This is not a forever isolated system. Depending on the type of flask, the type of container you are using, it could be isolated for a few hours. After that, the temperature starts decreasing of hot water. I mean, if you take a thermos of hot water, it's not going to stay hot for 24 hours. It could be 6 hours or 8 hours. And mostly, I'm not even talking about thermos here, some water bottles that we carry, few hours. The water will be hot for few hours, or the water will be super cold if we take cold water for few hours. After that, it changes, the temperature changes. So you can have an isolated system. There's no perfectly isolated system. It can be very close to an isolated system, but not an ideal isolated system. There is no ideal isolated system.